So over the past few weeks, you guys have been looking at Ohm's law and some resistance problems. And you should know by now that a basic circuit is going to have a power supply, have some wires, it's going to hit a resistor, back around to the power supply. And it's going to travel that way until that circuit is broken. So now what we're aiming at adding to this week is series and parallel. So to create a series circuit, it's basically all you're going to do is take another resistor, throw it into the circuit somewhere so that they're still in a complete line with each other, so that the electricity is flowing in one single loop. More resistors you throw in there, the more the resistance should be, which in turn means that your current should go down. One thing to note here is for the series, current is going to be the same through in all resistors. Now, to figure out how much current is actually flowing through each resistor, we will need to know a thing called an equivalent resistance, which is the total resistance for the circuit itself. The way you get that is you just add together all of the resistors that exist. So let's say if this one is here is 3 ohms, that's 2 ohms, and this one is 1 ohm. That would mean that my equivalent resistance is 3 plus 2 plus 1, which would be, so this would be the total resistance for the circuit, which in turn is what we would use to figure out how much current is actually going in this entire circuit. So if you remember, Ohm's law says if I know a voltage supplied, if I know a resistance, I can find a current. So let's say for the sake of keeping this easy, let's make that 12 volts. So if that was 12 volts, and I'm trying to find my current, and I know my resistance is 6 ohms, I'm simply going to divide those two out and get 2 amps of current, which would mean that there are 2 amps here, 2 amps 1/3 here, 2 amps 1/3 here. Once again, a circuit needs a power supply, you have a wire running to some kind of resistor, and back around the power supply. And we have one enclosed loop, and that would be a complete circuit. Now, if we were to create a parallel, so the parallel, what we want to do is make more loops essentially. So instead of having one single loop here, we're going to take the wires, piggyback on to essentially make another loop. So now you've got one loop flowing here. Then we're going to have one loop flowing here. So you're going to have two different currents going through. You're going to have one current here. You will have another current here. Now they both have the same power supply, and that power supply is being used up within each loop. So that means that if this was 12 volts, it means this resistor here is getting 12 volts. It also means that one down there is getting 12 volts.